Have a good lecture.
I was about to say the same thing.
Thank you, sir. I suppose we can get started. 8:35. Welcome to week 5 of Intro to Android. This week we'll be learning about sort of like a revamping of how to build your UI layer in MVVM with like MVVM in mind, and something called UI events. First thing, some announcements. Let's see. So A4 late deadline is tomorrow night, so make sure you hand that in. A5 was released, or at least that's the assignment for this week. Let's see, do Sunday as always. Um, and for the hack challenge, we have two like timeline things. As a reminder, hack challenge is like the final project for the course. Um, and so for the timeline for this week, we have like two events this week. Tomorrow, which is optional if you would like to try to find some other students to form like groups with, then you can go to this. Mixer tomorrow in Gates GO1 at 5 p.m. And in the same location on Friday, we have the Hack Challenge Kickoff, which is a required event where you'll like meet your teams and like have all that designated and whatnot. So make sure to like mark this on your calendar. And there's more information like an ed post that our vice team lead Antoinette Torres has like posted. But in terms of like the hack challenge, this is required, so make sure to show up to this one. And you can find more information about the logistics on Ed here on this post in like Ed discussion. But with that out of the way, we can get into our lecture content for this week. And so we'll start off with something I like to call dumb components, aka just like Vue/UI layer in MVVM. So as a quick recap, last week, we learned about this like coding structure called MVVM, and it's a good question to ask, like, or to remind ourselves why are we even using it. So, it's a lot to learn. Like this whole structure is kind of complicated, and what benefit does it have? Well, it certainly allows us to build like a real app with a lot of more complex functionalities. And so it's MVVM is really good for a really good structure for things like networking, having user input, asynchronous loading, stuff like that. That's all gets kind of complicated in the background, but is quite easy to handle in like the view model once you use MVVM. And the question more specifically for view models is why are we even using the view models? Like what purpose does it serve? It doesn't actually have any UI content. So what is the point? What is the point? Can't I just use state variables everywhere to handle the state? Um, the general idea is that it like is a really centralized uh, centralized center. It is a place where all the app logic can be handled very like separate from the whole like recompose life cycle of Jetpack Compose. And so in some sense, it is like an ultimate stakeholder where even if you want to do really complicated stuff, like wait X amount of seconds, make networking requests, blah, 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 the view model can handle all that logic without having to worry about any of like the UI layer recompose stuff. And so the general idea is like view model as a state is that the view model should tell each screen like all of the state that that screen needs. And so in other words, like that state, all of like a UI state should exist in the view model, and then the UI just listens to the view model to see everything that it needs to display. And that's a lot more organized than having all these like state variables and all the app logic being handled in the UI, where the UI is already complicated enough. Like if you're trying to use rows and columns and such to make your UI render how you would like, moving all of that over to the view model is a nice like organizational improvement. Um, and in order to allow this to happen, in order to allow our view to sort of be like state free, to basically take out all of those state variables, well, actually, you need to sometimes pull out state from our components and like allow the view model to handle state for us. So we can get into an example of like what that might look like. So I take this component, for example. This is in Lecture 5 demo, which we will look at in a second. And if you are trying to follow along with the lecture demo, make sure to like git fetch and pull because I changed a lot of things. But nonetheless, this component looks the same. So this is a like ticker row, kind of similar to the one that you saw in A3, where you can like see like stock, the price, and I guess the difference with this one is that you can like increase and decrease the price. I'm not sure who has that power, maybe like Elon Musk or something, but what this component currently does in order to get this to work is that it keeps track of that number, that like dollar amount internally. And so if you hit plus, minus, whatever, it will update the state internal to the component, and like the screen above it, the view model above it doesn't know that, doesn't care. That sounds convenient, but let's see why that actually limits our ability to network. So we'll do a quick demo of just like the code and walk through what I have for us. So here's the app. Nothing too crazy. It's kind of just like a screen where you have a bunch of stocks and you can press like plus to increase it and the minus to make it go back. And if I scroll around, you can actually see that that's kind of a bug. Don't worry about the numbers popping up here. If I scroll down, then there's like this back to the top button that appears, which we will implement later. But just looking at the components, here's our ticker row. And in ticker row, I have like a little preview here. I guess I can just full screen this. And yeah, this is the component that we like sort of want to use as like a case study, I suppose. So this component again has like, well, this is what you saw before in the slides. And if you look at the code, if I and make it a little bigger, you'll see here that the price here is being monitored by this internal state here. So we have like a mutable state of, it's a mutable double state of, don't worry about that. It can just be mutable state of as well. That sort of internally handles the price. And so if we look at the on click here for like the plus button that we have and like the minus button, this is another component that we use. Or this is another component that exists in the code base. Then the onClick just sort of takes that price state and either increments it or decrements it accordingly, and the text will take the value of that state and render it. Pretty simple. And this is definitely what like a component you would come to expect with something from just like week 2 of the course, right? The general issue, though, let me check if the slides start talking about this. Yeah, well, I guess that's just sort of like the code walkthrough. And on the ticker screen where this is being used, you can see here that we have, oh, don't worry about the to-dos. We basically have just lazy column, a bunch of those ticker rows. Very similar-ish to A3. You have a bunch of these ticker rows and like a little horizontal line spacing between them. But yeah, these ticker rows are being called just like one after the other, blah, blah, blah. And they're given the ticker and the price. Okay, so going back to the slides. The general problem statement is that, like we saw before, that the ticker row keeps track of its own price, like internally. And it has like definitely some pros in that it's like somewhat convenient and but some cons as well. So in general, what's nice about it is that we don't need to like manually implement add or subtract. So internally to the component, like pretend I was another developer just using the component, like it was already finished. I wouldn't have to manually implement the add and subtract myself. That sort of logic is just baked into the component, which is kind of nice. Therefore don't need like an on click, like a on add click or on minus click. It's all just sort of implemented internally. And the idea, anyways, with like that price argument that you saw is that it only takes like an initial price argument. And then after that, I don't have to care about like how it's being handled, which is, again, like less burden for like the user of this component. But the cons in general is that I have less control over the component. And so something like the view model wouldn't be able to dynamically update the ticker or like the price that you see there. And that's really bad if it comes to like building a real app where we want like a lot of control over things. Oops, there we go. So why is that really bad? Well, let's take a look at what's actually happening in our view model right now. So you saw the code, you saw like how I was walking through and like interacting with the app. Let's actually see what the view model is trying to do right now. So I'll hop over to the view model since I already implemented some logic there. So there's actually quite a bit of stuff in here. So there's 2 files. I guess I'll just go over this one first. Um, this is just like a mock networking function in this like ticker repository. It's fake. It doesn't actually do any networking. It'll just wait 400 milliseconds and then return like a random value. But pretending that that's like a real networking value, you can see here that I have like a UI state that's giving like all of the stock information down to the screen. That's like the idea of view model being a state holder for the screen. Um, and you can see here that on init, this is basically like a constructor, aka this will run when the screen like first opens. It will wait like 500 milliseconds and then start loading. Basically, fetching from like a server, which obviously doesn't actually exist, but let's pretend that that server exists. So basically, I mean, you don't have to really care too much about how this code is working. This is more like, I guess some of this code should be relatively familiar with like the dot copy and stuff. Basically, all it's doing is like iterating through all the tickers, fetching with that get ticker value, like fetching the value that that ticker should be at from our like server or whatever. And then it's just like sort of setting it to be the new like the new stocks that the screen is being given. So every time a stock loads, every time a stock loads, it'll send down to the screen over and over and over again. And so all of this logic is actually implemented and it's correct. It's tested. It's correct. And you can see here that the UI state here is being given and read actually correctly from the screen. And so the stocks here is being used with like the collected state. All of this looks totally fine. All of this looks very correct, except the ticker row, like basically everything here is correct, except the only thing is that just based off of how the ticker row is implemented, the like all of those prices that are actually being loaded in the background aren't rendering onto the component based off of the like internal price state that we saw before. So I think there's a stopping point, or I guess that's the general idea. So we have all this like networking logic that's being implemented, or that's already implemented in the background, except just based off of the way that ticker row is implemented, it's not actually using any of it correctly. So any questions about these two files, or I suppose anything with like these three main parts of the MVVM that we have here? Any questions? Okay, cool. And nothing on Zoom, I believe. So if that's the case, we can sort of go into why ticker row isn't working. And so, well, yeah, the idea for the fix, anyways, is that we can sort of make ticker row like a less like intuitive or like a less useful component in order to get more control over it, aka like dumber, as I like to call it. So instead, what we can make ticker row do is like really make it like a really sort of unintuitive component. So in some sense, we can do this. So once the plus button is clicked, we'll just give an on click. When the minus button is clicked, we'll just give an on click, and then we'll just implement them by telling the view model. So at every single point in execution, we can just rely on the view model to tell the ticker row, like each ticker row, what the correct price is to show at any point. And within ticker row, we are not going to like do any addition or subtraction actual logic, like add one, like the actual adding one minus one will not actually happen whatsoever in ticker row, even if it seems intuitive, like, oh, even if I'm pressing plus, it should technically go up. We theoretically could implement ticker row with those plus and minus buttons to just like do nothing. And so in other words, we'll just convert the plus and minus to on clicks, simple on clicks, and just tell the view model that the clicks occurred. And quick, like very professional demographic, you can see that the ticker row before could determine the new price on its own. Every time you hit plus or minus, it would perform the addition or subtraction on its own. But now, even though like the idea of addition and subtraction seems intuitive, we'll sort of take the brain out of ticker row, say, and now ticker row will say like, oh, I have no idea what these buttons do. I have no idea what add or subtract does. I'll just hope that the view model knows what to do for me. And you can see here that the brain that's sort of pulled out is the brain of like the view model in some sense. Okay, and let's go ahead and implement that then. So the general idea is to make this component like a little dumber. So let's certainly just get rid of the state. And the general idea is that the price that we pass into the row will just always be the correct one. Theoretically, let's say I just changed the price a bajillion times and it made no sense, and I didn't press any plus or minus buttons. The ticker row would still look at that and just be like, oh, the view model is telling me that I'm getting some price. I'll just display it and trust that it's like displaying the right price. Sort of blindly, we'll try to just trust that. And so just like instead of using like that state value, we're just going to, again, use this argument to just like blindly trust that we're being given the right price. I'll just get rid of that preview. And instead here, okay, well, we no longer have this state to add and subtract from. And indeed, all the component will know is that like, oh, this plus button, whatever it means, is pressed. I should tell somebody about it. I don't know what it does. I'm just going to tell somebody about it. So, oops, let me disable my autocomplete. So basically, I'll just say like, oh, on add clicked, I'll just tell somebody that my ad was clicked, and that's just like a regular anonymous function. Same thing for the on subtract. Oops. On subtract clicked. Okay, so now with these two functions, I'll basically just like say, oh, I'll just tell somebody that add was clicked, and I'll tell somebody that subtract was clicked. Even though like the idea with these buttons is to like +1 and -1, we're not actually going to implement that in the component. We're just going to tell somebody else that add was clicked or that subtract was clicked. And we can do that just here to get it to compile. Let's just make it do nothing. For example, in this preview, adding now would do nothing and subtracting would do nothing, for example. But in the screen, we'll make sure to implement that actually correctly. So if we hop over to the ticker repository, actually, you'll see that I've already given this like view model function that is like corresponding to like, oh, you clicked a ticker, or you clicked like a plus or a minus on a clicker. Yeah, don't worry too much about like how this syntax is working. Basically, it'll take a ticker and then it'll change the amount by like the amount that you put in. So we can use that here. So let's say that when you click add, you will use that function to use like +1. So we'll say ticker view model dot on ticker button click with the ticker, which happens to be entry.key. I probably should name that something else. And +1, or like I guess just 1, right? And the subtract on subtract clicked will do the same exact thing, except oops, 1.0 minus 1.0. And so you can see here that I've actually pulled out that sort of information and said that the screen has to implement that +1 and -1 now, which again might seem a little unintuitive, but the sort of benefit that we gain from doing this is that this price value is now like completely under our control, right? Since the entry.value, basically this is just being given from the stocks, which are being like broken down into the ticker and the value. So we get the stocks thing, and stocks, which is a field of the UI state, is completely under control of the view model. And so if we do fancy stuff in the background, like load at runtime, like load, fetch some data from our server at runtime, then we can have like complete control over what is being shown on the screen in this view model, such that once the ticker values actually load with the function that we saw before, they will correctly be overridden on the screen. And so if we take a look here, building, right? Might take a second, hopefully not too long. Hopefully we'll see, or what you would expect to see is that like sort of after we load, the stock prices will just sort of like filter in one by one by one by one by one. Hopefully this doesn't take too long. That would be a little awkward. Okay, cool. We're back on. So you can see that once we launch, if it launches, there we go. You'll see that all of them start loading in one by one, just like that, with our like supposed networking functionality. And you can see that all of them now have loaded to supposedly anyways their correct values. And still, if we hit plus or minus, then those stock prices will go up or down. So in sort of summary, we altered the component to take the state out and give it instead to the view model. In essence, we made the component like dumber because we have to implement the +1 and -1 like ourselves in the view model. But that still, though, allows us to use the component like completely. We have complete control over the component, even if it's a little bit less intuitive. Okay, so in general, I mean, this is sort of just like a reiteration of what I said. Generally, the like pros with this approach is that we can like dynamically update the price with like our complex networking calls. Um, as a general con, though, is that we have to implement that like addition and subtraction ourselves, like again in the view model, which like you saw that function before was kind of complex. That kind of trivial addition and subtraction in the VM, like you have to write that function, you have to connect it up in a bunch of layers, and it's kind of just like annoying code to write. But that Pro is really nice because now we can like build a real app that uses actual complex functionality, such as doing networking calls. Um, and so, in general, the reason that the view model is like so useful to like why pull this all out into the view model anyways? Why not just do it in the screen? Because the view model exists in like a separate sort of life cycle from like the recompose life cycle that's always rerunning your function over and over again, and so you don't know what values like your what values your states will hold at any given point. It's super easy to do logic calculations in there since it's just like regular coding. You can just do things like you normally would in any other programming language. But if you tried to do the same thing in UI, you'd get like values being lost. Like if you ran networking calls, who knows what happens if the screen refreshes midway through your networking call, stuff like that. And so the view model is just like a really convenient place to do more complex networking functions and things like that. Okay, any questions on that whole like UI layer revamp stuff? Any questions? Nothing from the online folks either, it seems. In that case, we can move on to these last two parts are somewhat related. And this first part here is a little confusing, but we'll hopefully get into like a better use case of it with part three. But for now, we can go over launched effect. So a brief summary of like what launched effect is. And again, a lot of this won't really make sense of like why it matters until we get into like the next part. Launch effect defines function that like basically watches one value and it has like a function that will fire whenever that value changes. So like it has like an anonymous function afterwards, and it takes in that one parameter, that value that it's basically watching. So this is the general like structure of it. In this case, that value that it's watching is state. And so whenever state, in this case, this is like an actual launched effect that is on our app resell. If like the state of this button changes, then it'll like wait 100 milliseconds and then like change the state, like animate the state to become something else. But yeah, that function there will fire whenever the state changes, that like state value changes. To like cause the animation or whatever to happen. Oops, this thing is blocked. There we go. So here, launch effect allows us to perform like some UI level logic. Whenever a button goes from like loading or not loading, for example, this like animation will play, which is kind of nice because doing all of this in our view model and telling the button, although it's possible, is kind of annoying. And so it's nice to do some like UI level logic with launched effect, like where possible for things like small animations and stuff that the view model actually doesn't need control over. And so like as a bit of like an infographic, again, once like the state changes, it'll actually like wait a little bit, like wait 100 milliseconds before showing this animation just to like improve the user experience a little bit. And so while some, or I guess this is like another reason to use launch effect, while some, or while like of the vast majority of your app logic is done in the view model, there's like a very few things, like very few functions that you can only call within like the composable scope. You've probably seen this or like run into this bug yourself where like you write a line of code and then it says like composable functions can only be invoked in like a composable context or something like that. This is basically like what that means. So things like like, oh, if you're going to call like remember so blah 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 state, that can only be called in a composable function. Same thing with something like a nav controller, right, for navigation. If you tried to call remember nav controller for your nav host for what like A3, in anything but a composable context, it would just throw an error because some of those functions could only be called in a composable. And so as a limitation, some functions can only be called they need to be called in a composable layer, aka your UI layer, um, in order to like be used. And so this is like an example of a real function that can be used for something like the scrollable modifier if you put that on a column to make it scrollable. And you can see here that it has the composable annotation. Even though it isn't a UI component necessarily, like it just basically gives you this like this scroll state that allows you to do things like scroll to the top, scroll to the bottom. It's still a composable function, which means it needs to be called in a UI scope or like in your UI layer. And so the overall idea of this, and again, this like you don't really have to like it might be a little bit unclear where this will come in handy. The launch effect allows you to write like UI level logic. Um, and so like again, for the vast majority of cases, like the view model should have like 99% of your app logic. And so this is like very reserved for like those UI only cases where you need to use your UI layer for whatever reason, as we saw on the previous slide. And again, bit confusing. That's okay. We'll dive into like the most useful example of this with UI events on the next part. So without further ado, let's go into UI events. So the general niche with like UI events is that like launch effect can handle a bunch of different things. Like you saw, it was doing like some animation stuff in that button before. Um, uh, yeah. So the general idea is that launch effect and view models will like encompass almost everything, but there's like one kind of like specific use case that the UI event is actually like really useful for, and you'll see happen kind of a lot. Um, in a lot of cases where you'll want to use like UI level logic, you need like a this one-off event firing pattern. So what that means is that, for example, if you want to click a button and have scroll to the top occur, which we'll implement in a second, um, you want this like scroll to the top to fire once. Like once you hit that button, it scrolls to the top, and it doesn't happen again until you click the button again. And so like you can imagine that there's a lot of ways to implement this wrong, such that like you click that button and then like maybe if some flag like goes from false to true, but if you keep on scrolling down, it would just keep on firing. So we want it to just fire like once and never again. And we want to this is like another implementation sort of detail where we want to be able to fire multiple of these events in a row and like have them not be ignored. So there's a few like ways if we were going to, for example, implement clicking a button to cause a scroll to the top occur. Like there are a few ways you might want to implement this, or you might like think are a good idea to implement this. So for example, what if we had like a state flow that like just implemented like a Boolean, right? Or just gave the screen like a Boolean. Oh, like immediately it's false, but whenever we should scroll to the top, we'll just emit true. And so whenever in the UI you see true, you sort of cause that scroll to occur. Well, in one way this would be wrong is that if you click the button afterwards, like if you did dot value equals true, and then 2 seconds later you press the button again and cause dot value true to happen again, the value is the exact same, so the flow won't actually change or like emit any value, and so it'll emit the first true and then ignore the other. So if you made it in your UI cause a scroll to the top, the first one will cause a scroll to the top, but then the second one will just be ignored. It won't fire any flow event. And so like another thing is that like how does the screen theoretically know if this true is still actually like important? For example, if we read the true and then like use the stuff later on and then the screen recomposes and it's still true, how does the screen know that like should I take that true as like still true, or should it be or is it like a stale true? Like is it not useful anymore? So like what if the event was already used in like a previous recomposition and the screen refreshes and then should I still use it? So to like sort of fix these problems, we have this like UI event class, this UI event idea. And so this is like the general syntax where now instead of like a scroll value that's just like true or false, we have like we use like a scroll event, which this is at least the syntax of how like the example uses it, where it's like a UI event and it takes a generic type, in this case unit. And I think the next slide, yeah, breaks it down. What does the syntax mean? Um, so the flow that we have here emits UI events now instead of like Boolean values, I guess. So each UI event will optionally contain like a package of data. Like say, for example, I wanted to scroll to a particular item in the list, I could like put that as integer or something like an integer index. In this case, we're just going to always scroll to the top, so there's not actually any important data there. We'll just always scroll to the top every single time we see this event. And so we'll just say it's unit, aka nothing at all. That's the equivalent of like void, I guess, if you know Java, or like null in some sense. It's very similar. So unit basically just means like no data. And then we'll initialize the flow with null to indicate that there's no event. You should not scroll to the top. Nothing's happening. Or like you should not answer this at all. And then this event or this line of code. So when that like back to top button is pressed, we'll create a new UI event. Again, with no payload, it's just unit, and then send it down to the UI to notify it that like, oh, this event occurred. You should scroll to the top. And so this is like the kind of funky syntax that you'll probably just like need to sort of copy later on because it's like not incredibly like it's kind of weird. But or it's not like incredibly easy to remember. But basically the idea is that once you get that event, you can consume it, aka like mark that it has been used, like we're not going to use it anymore, and then scroll to the top once that event has been sort of received by the screen. So again, this is in your UI. This is in a screen, and once you receive this event, you'll like consume it, mark it as like, okay, this event is not being used anymore. Like I've already used it. And then I'll scroll to the very top. So again, this like line of code kind of consumes the event. The question mark there makes it so if null is the scroll event, it won't do it. So like in the beginning, you don't want that event to fire like immediately. We pass down null, and the question mark will only fire like or the rest of the code if it's not null. So in any case, this will consume the event. And after the event is quote unquote consumed, it will never be recognized again by any further like recompositions of the screen. Let's see. So because of the way that UI event is implemented, you don't really have to know why. Whenever we call like a new UI event or construct a new UI event and send it down, even though it looks identical, even though like before we had like, oh, you send down true, you send down true, there's like the same value. Even though these look really identical, these will actually call or cause two separate events to be registered by the UI, which is nice, since we still want to be able to scroll to the top, wait 2 seconds later, and then if the user wants to, scroll to the top again. You don't have to know why this is. This is just how it's implemented. And the actual idea is that UI event, or I guess our little secret, is that this is not something that Jetpack Compose gives you. This is actually something that we/I wrote. There's the entire source code in Tiny Font if you're interested. It's not very long, pretty small file. We'll give this to you like in your assignments, and like for the hack challenge, you can just copy it. But it's not an extremely complicated file. Most companies probably have their own version of this class and like in whatever Jetpack Compose stuff they're doing. But nonetheless, you can use our source code here to like get all of this functionality for you. And I guess that's like a stopping point, but as I guess like a final word to wrap things up, that was all kind of complicated, but all of that encompasses nearly like every single case of app logic that you'll run into in developing like a usual app. And so we'll get into a case of how to do that in the demo right after this. But with that, basically all of like your app logic, all complex app logic besides networking, which we'll do in week 6, is all like in your repertoire now. You can totally do that for like the hack challenge and stuff. But yeah, any questions on that? Since it is kind of confusing stuff, hopefully an example will clear it up. But any questions I can answer right now. Okay. Um, if there is nothing, then we can move on to like how to use this in our screen that we had previously. So you can see here that the UI state actually had this scroll event already. And so the scroll event here basically, again, represents like, oh, a scroll to the top. So if I scroll down a little bit on my app, you can see that, uh, oops, you can see that the back to the top button occurs. If I press it right now, nothing happens, which is sad, but uh, we can see that it like only pops up once we scroll a little bit, back to the top occurs, and hopefully once we hit back to the top, like once we press this, the scroll will occur to cause the screen to like scroll back to the very top. Um, so let's see. If you're curious about how the like back to the top is only being shown once you scroll a little bit, this is the code that does that. Um, or like this is like an animated visibility to make it like fade in and fade out instead of just appearing. But apart from that, this is the code that does it. In essence, all it is saying is like it's reading the scroll state of the lazy column, the entire lazy column, and saying that if the first visible item index is like not zero, greater than zero, aka like right now it's zero. If I scroll the zero off the screen, it'll be one. Now two, three, four, blah blah blah, so on. If I've scrolled past zero, you can see that the back to the top pops up, and ideally, once we scroll to the top, we'll hit the very top, and therefore the button will automatically disappear anyways. So I think right now we already have this, yeah, this on scroll to top clicked implemented in our view model. And basically the view model says that, oh, I can't actually cause a scroll to the top to happen because scroll to the top can only be done with this scroll state you see here that's passed into the lazy column. We need to call scroll state dot animate scroll to item zero in order to cause that to happen. Like that's the line of code to cause a scroll to occur. And scroll state, the view model, does not have a reference to scroll state because this is something that needs to exist in the UI layer. You could imagine like because it's something that is very important to like render the screen, like the scroll state, in order to cause or in order to allow this to work with like the recomposition lifecycle, remember lazy list state needs to be a compose function. So you can see once we roll over it that this is a composable. And theoretically, if like, for example, we were going to try to call that lazy list state, you see it throws an error. Composable invocations can only happen from a composable function, aka your UI. In other words, this line of code needs to exist in your UI, and therefore you can only reference this in your UI, like the scroll state. So in order to cause the scroll to happen, we need to basically tell this like composable function, our screen, that the scroll event occurred, and therefore we need to scroll to the top. So in order to do that, we can, since everything in the UI is already implemented, like this scroll event is being sent down to the screen, we're just not using it. So right now we can start using it by just saying like, just like we were using the stocks here, we can get the event. So scroll event equals UI state dot scroll event, and then use that syntax that we saw before. So launched effect on the scroll event. And so that basically makes it so this curly brace function that we're passing in will fire whenever scroll event changes, just like the value. And again, that could also change when it goes back to null, for example. So we want to make sure to use this this consume suspend. And so this will make it so like the question mark thing will make it so if it's null, it just won't do it. And the consume will make it so that like if the event is like a new event, the brace will fire, otherwise not. So if it's a stale event, like this is the second time a recomposition has occurred and we see the same event, then this won't fire again. And so with that, we can do the scroll state dot animate scroll to item. If there's like a little nuance here where like theoretically there's also a consume without suspend. you'll just see here that animate scroll to item it needs to be an asynchronous like coroutine function, which we'll learn about in week 6. So don't worry too much about why we're using suspend. For now, in order to do something like a scroll to an item with anything that has this like suspend fun, you'll need to use the consume suspend. But yeah, don't worry about that until next week. But if we reload this, hopefully this works. And so what we'll expect to see is that because like the view model is now telling the screen to scroll and we are consuming it like this, once we click this button here to cause on scroll to top to be fired, this will sort of again tell the screen to scroll to the top and we can cause this to fire. So let's see if we scroll back to top and you can see here that it scrolls all the way to the top. It's kind of fast. I don't know if you can see that, but it sort of animates a little bit, scrolls to the top. And naturally, whenever we scroll to the very top, the first item index becomes 0 again, so the button will disappear again. But if I scroll manually, oops, I have no idea why I just closed. That was weird. Maybe I have a bug somewhere. Let's reopen that real quick. If I scroll again, yeah, I'm not sure why I just crashed. That was kind of weird. But if I hit back to the top, it'll scroll hopefully back to the top like that. Okay. So that's the general idea of how to use UI events. Something that's not too important, I guess we'll go over this very briefly, is like this other component that I made, ticker text. This is definitely not too important, like knowing how this works, but this is an example of like launched effect being used to let's see it's being used to indicate like an increase or decrease animation on a ticker. And so the general idea is that if the ticker has like previously increased since its previous value, it should be green. Otherwise, it should like if like the stock has recently decreased in price from what it was previously, it should be like red. And that logic is it's somewhat complicated with this like launched effect stuff. We won't have you write anything like this in assignments, but you can see here that I'm actually using like internal state here to cause this animation to occur. Basically, whenever I'm given a new price, I will look at what my previous price was and mark. If my price is larger than what was previously, then I'll make sure to mark it as like an increase. And if it's an increase from what it was previously, I'll have it as green, otherwise red. You could imagine that I could do this logic also in the view model, but it's really annoying to do that for every single ticker. And so it's nice in some cases to like implement animation logic like this with like within your components, but those cases are pretty rare. And it's only like a very small, nice little finishing touch to your UI. So if I wanted to use this, I could use ticker text with price equals, what does it take in? It's a double, so just price. And it was taking in something else. Oh, just a modifier, which I don't think we need. And so let's just see what happens if we use this new ticker text. And so again, if I recently like increased a price on the ticker, hopefully it's green, otherwise red. Let's see what it looks like. So you can see here, maybe I should have shown like a little bit darker of a shade of green because you can't really see that. But if I hit minus on this, you'll see that it turns red. If I hit green, it'll turn back to like green. Or if I add to it, it'll turn back to green since I recently I don't know, it's closing recently like added to it. But yeah, that's like a little bonus example of how you can use like internal animations with your launched effect to like do really small, tiny little animations for your component that would otherwise be definitely really annoying to implement by hand in your view model. But yeah, well, we won't have you write that for assignments, but make sure to take a look at that if you're interested. Okay, yeah, and that's all we have for today. Here's the attendance form. Thank you very much for coming. We can stay for a little bit afterwards for questions, so stay on the lookout for that. But apart from that, that's everything we have for the week 5 lecture. Thank you for coming.